want to have a look at how we can assemble the phone holder that you've been building in your DT classes. You will have built the base and the upright and then the bolt, and then be making the acrylic stand for your phone holder like so. Okay. To do this, you're not going to have to make the parts, they're already made for you. If you go to the online assembly practice section of your classwork in Google Classroom, have a look for the phone holder assembly, and there is a link here that you can click on and then make your own copy of the file from the shared area. Okay. Once you've got your own copy, it should look like this with your elements at the bottom and one assembly already done, but you're going to make your own assembly for this. Okay. So to start off with, let's have a look at some of the parts that we've got. So we have the base, which is like so. So this has the drafted edges to it, and the hole in the center, which is 40mm by 20mm, 44mm by 20mm. Okay. Then we have the upright, which is this part here, which is going to slot into that hole with a hole pre-drilled through the top there. We have the bolt assembly, which is this part here, and we have the acrylic part here that we had to go to actually drawing. Right, so let's start to assemble this. So I'm going to create a new assembly. You will already have a blank tab, I think, or you may have to create your own assembly to start off with. Okay, that will open up like so. Start by going to Insert, and that will give you your parts here. Start first of all with the base. Okay, bring that in. This should be the right way around set up, so we want to get it roughly over the origin, so you can move that around. Yeah, that's fine. And then if you right click and fix that so that nothing else can actually move. Okay. Then we can insert our next parts. So let's insert the upright. There's the upright, like so. Green tick that. Now, I would suggest that the mate to use for this would be your planar mate, similar to what we've already used. So planar mate, zoom right out so you can see. So we're looking for the center of this tool. Yeah. And then zoom in and find the corresponding surface that you want to use. Remember, you can use your middle mouse button to drag around. Now be careful, because that is not the surface that you want to be on. You want to be on this surface here. So zoom a little bit further in. There we are. So that surface, and that's the mate that you need. Click. Now, you may find that the object appears to be the back to front. Remember, you can use your reorientate your axes. So you can use that. Yep. And you can also use the arrow key to switch it around and then reorientate until you've got it how you want it. Green tick. Now remember, that will only, you'll always get a second planar coming up after this. Remember, that will only limit its movement, so it can move like so, but it can't move from left to right, or it can move, yeah, because you fasten it against that surface. Okay, so let's rotate this round. Let's put another planar mate to lock it even further. So on this surface here, again, zoom right in so you're on that surface. There we are, that mate there. And then we're going to look for the one on this surface here. There we are. Yeah, and then that's linked in place there. Green tick. And that should now be linked or locked down. If we look at a top view again, there's our part from the top view. Try and drag it from up and down or left to right, it won't go. However, it will move up and down inside the hole there. Okay, so we need to lock it down further. So to lock it down further, I'm going to turn it all the way around. Drag that up. I'm going to put a planar mate on the bottom surface here and the bottom surface of my base. Okay, now it moves to that center point. Don't worry about that, just green tick it and then it will move to its correct position there. Again, you can close the remaining planar that's popped up there because you don't need that one. Right, so if we rotate that around, that gives us our upright and our base in place there. Okay, so the next part what I need to do is to bring in the other part. I'm going to bring in the acrylic part for this. Okay, so we could try and position it over it, but it's not going to be very accurate. We want to try and get it on the center of this part here. Now, if we try and actually use a revolute mate for this, there are mates that are available, but nothing really sits in the center of those two parts. So we're going to use the similar sort of method that we use with the crank. So we're going to take I'm going to create a new mate, okay, and we're going to put this one between two entities. And the two entities I'm going to choose is going to be the inside surface here, and that inside surface of this this shape here, so there. But make sure you're actually on the inside of the slot, if you like. So that's there. That's one mate there. And then we're going to turn it around, and we're going to do the same thing on the other side. And again, you may want to just sort of rotate this around so you can see inside here. Yeah, and we want to find the inside surface of this area here. So the other entity is going to be inside here. Zoom right in so you can find it. So that surface there, and that should have picked a place in between those two entities. Let me just zoom this out. There we are. And there's our new mate set in place there. So it has its orientation based on what it had on this side here, and then it's lined it up with the center here. So that should be nicely in the middle of our slots there. Okay, ready to be used. Let's green tick that. We don't need to realign it. I'm happy with the orientation for that. Okay, so now we can then revolute mate this with a mate that's in the center of this object going through this hole through here. So pick up my revolute mate, find the center one, so there's 1, 2, 3, pick the center, and then on here we'll pick our new mate that we've just created, this one here, click, and that should move into place on here. There we are, that should be nicely lined up over around our hole there, okay? Right, so let's move to the front of our device, and the orientation appears to be correct for the base as well, because the base is here and we want our phone holder to be on this side of it. If you find that it's on the other side for it, okay, remember you can go back to your Revolute and you may want to just change the orientation of it on here to get it to be the right way around for where you want it to be. You may need to flip it around if it's facing the wrong direction for you, okay? I'm happy with that part there. Okay, so now we have our mate in place. I just want to re-examine this little element here for you. Okay, one of the problems that can occur is the order that you actually select your mates here, because what can happen is that it then thinks that this is the moving part and this is the fixed part, because of the order that we've actually clicked on our mates here. So if I was to play this, you can see here the upright becomes the part that moves and not the acrylic part. So we need to be careful about which order we actually pick this in, these. So we can reorder them, or we can drag them, but sometimes you just need to reselect them. So I'm going to just delete out these mates again. I'm going to then reselect them in the correct order for me. Okay, so pull this out here. So I'm going to pick my new center mate first, and then I'm going to pick the mate inside the upright. Okay, so now the order is acrylic first, and then the upright. So what we're saying is this will turn around this part here, or rather this will turn around this part here, I should say. Okay, let's green tick that. Now, if we open this up again, and we look at our side view here, and we play this, we should see, there we are, our acrylic part moves around the upright. Okay. Now, one of the problems that you can see is that when we start to drag this through, it goes through the element here. Just green tick this. When you drag this through, it physically goes through the item. Okay, can't see it. To this view, you can see it goes through the item here, which physically it can't do. Okay, so what we want to try and do is to limit its movement. So to try to actually limit how far the object can turn, we're going to try and actually implement a limit to the object, so that when it physically is dragged here, it can only travel a certain distance, so it stops when it reaches things. To do that, what I've done is applied 2 limits here. So I've clicked on the limits, I've actually typed in values here, minus 93 and 93. We can see the effect of that if we look at the side view of our object here, and if we hit the play button, you can see that it comes round, it hits that point, then rotates round, and then and that's the limit of how far it can actually go for that. Okay. If we want to test that further, the green tick, and if we right click on here and go to animate, and then play animate here, we can actually see the whole movement happening. So this is the limit of its rotation as it goes round. So it's going to hit onto this point here, and then continue rotating around until it hits the other part. Remember, you can increase the speed of this by adjusting the number of steps, reduce the number of steps, and it will go faster for you. Okay. Okay. So now we have a physical limitation on how far it can actually turn. So start value of minus 93, and end value of 93. Okay. Stop. Okay, next part we want to put in. We want to import in our bolt. So to this, I'm going to go Insert. Have a look at inserting the bolt. Now the bolt will come through in two parts, okay, for us. Okay, a physical bolt there. We also have a nut, which is probably hidden somewhere here. Let's just hide the other parts for the moment, just so we can find that. There we are. There's my nut. Let's just move that so we can actually see it. Let's put everything back in place. Don't want to lose your nut. Okay, so. For this, we're going to use a revolute mate to put the bolt going through, and it's going to go through this hole and use the center of our device. I'm going to actually just hide this mate here for us so we don't get confused by that one. Okay, so I'm going to take the revolute mate. Okay, I'm going to pick the center of the bolt that I can find, which is going to be the beginning of the thread here. Okay, this one here. And I'm going to find the center of my upright here. So there's 1, 2, 3, that one there, and this is the hole that's going through our part here. Okay, we'll just green tick that and just see where that lies. Now, you can zoom in. You see how the bolt appears to be in place, but it appears to be set inside the acrylic. Okay, so what we can do is we can use our revolute offset to adjust that distance for us. So the minute this is our center here, so we need to move the whole bolt out by 3 millimeters. And the direction that we're going to go is -3, so -3. Now 3 is because this is 3 millimeters thick, the acrylic, okay? And that should just sit nicely outside our acrylic there, okay? The next part to put onto it is the nut that's going to sit on here. So I'm going to insert, and I've already inserted the nut on there. There it is there. Okay. That's my nut. Okay, let's move that out just so we can see it more clearly. Okay. We're going to then put this onto the bolt here. Now again, the order that you do this is crucial. So I'm going to take my cylindrical mate this time. Okay. And I'm going to scroll onto here, and I want to find the center of the face here, the end of my bolt there, and then I need to find the center of my nut here. So now this can be tricky to actually find, so make sure you zoom right in so you can, and you have a clear area to look at. Now what I find with this is if I move to the edge of my shape here, then I get all the sort of possible mates appearing. There we are. And I want to get that one with so there's one here which is not the one I want, that's offset. We want the one that's in the middle here. Okay, that one, that's the center of my hole. There we are. Okay, let's see where that is. That should have gone on the end of the bolt there for us. Okay, let's green tick that. Zoom in. Okay, so that's just that nicely there. Okay. Now we might close this one. We can switch it round by switching the direction that way. There we are. That's now set onto the bolt there. Now we can move this along, so we can physically just drag it and pull it along. But if we want it to actually sort of turn on the thread, we can use another mate, which is this one here, which is a screw relation. you click on that. The mates that are going to be using for that we used in our cylindrical mate here, so we can just select that. That becomes here, and the revolutions per minute, or the distance per revolution that it turns, well, that's determined by the pitch of our thread here. Okay, so I know the distance between each of these is 1 millimeter. So if I then put this as 1 millimeter here, and then green tick that, okay, that should mean that when I move my nut along, that screw rotates through 1 mil per revolution as it moves along. Okay, that's moving along. If we were to turn just the nut, the thread also turns at the same time for us. Okay. Now, if we don't want that, if we want this to be fixed, we can fix the bolt first. So fix there, and then if we just take the nut, as we turn this and drag it through, it will rotate as it's moved through the thread there for us. Okay. Okay. So again, it will look a bit more realistic on our final design. Let's swing this to an isometric view. There we are. Okay. And again, if we grab this, we know that this can seesaw down, but it will stop when it hits that point, as it would in the real world, and it will stop when it hits that point there because of the limitations we've placed on this. Okay. Right. When you've done that, make sure you take a screenshot and upload that into the area, and you could also use the screened GIF app on the desktop to grab a screenshot of a little movie of your model and upload that into the classroom as well. Okay, well done.